The Earth's continents are constantly changing. Join us as we explore the ancient geography of our dynamic planet.
Paleogeography. To answer questions about the ancient geography of the Earth in order to make comparisons with the present-day geography, it is necessary to make maps of the lands and seas that existed during past ages. This process of reconstructing ancient geography is called paleogeography, from the Greek word palaios, meaning ancient. Like a modern-day detective, the geologist must search for clues about the nature of the ancient geography among the rocks. The clues are of two main kinds: the types of fossils preserved in rocks and the properties of the rocks themselves. By studying these clues, the geologist gains direct knowledge about the distribution of the lands and seas and also the natural environment of the area, such as climate, the temperature and salinity, that is, the salt content of the water, and the downhill direction of slopes on the Earth's surface. The last item is very important in helping the geologist to guess where the mountains and basins were located in the geologic past. The distribution of fossils, skeletons, shells, leaf impressions, footprints, and dinosaur eggs in rocks can provide information about the ancient distribution of lands and seas. For example, the remains of corals and clamshells, sea animals, in very old limestone deposits indicate that the area was once part of a shallow sea. Similarly, when the remains of ancient animals, such as horses and camels, are found, it can be assumed that the area was dry land or that land was nearby. Fossils can also show the depth and temperature of ancient waters. For example, certain kinds of shelled sea animals live in shallow water, others in deep water. Certain kinds of present-day coral need warm and shallow tropical saltwaters to be able to live. When similar types of coral are found in ancient limestone, it can be surmised that the area at one time had a warm, tropical climate. The properties of rocks are also important clues about the ancient past and are used as guides to reconstruct paleogeography. In 1863, the famous naturalist Louis Agassiz helped to solve a mystery about the origin of certain kinds of rocks, containing a mixture of sand, silt, and clay. Some experts thought the rocks originated during the biblical flood, but others suggested that they were caused by sediment, that is, anything left behind from melting icebergs. After a summer in the Swiss Alps studying glaciers and glacial deposits, Agassiz discovered that the rocks found, for example, in much of Europe, had been spread by large continental glaciers. Much of what Agassiz saw could be explained only by glacial action. Because a glacier is a solid mass of ice, it moves slowly, and as it moves, it picks up all sizes of debris. In other words, the scattered remains of broken particles, ranging from huge rocks to silt and clay. As the ice melts, all the debris is left behind in the form of a layer or material of many kinds. Using these two important clues, fossils and rocks plus other information, geologists are able to reconstruct ancient geography to make comparisons with the Earth's present geography. By comparing these, geologists know that the appearance of the Earth's continents has been constantly changing over the centuries. And this changing of the Earth's surface is still going on today, but it is so gradual that people are aware of the change only occasionally. Earthquakes and the formation of new volcanoes are two spectacular actions used by nature to change the face of continents. Truly, we live in a changing world.